Okay, to continue, we have a problem. An equal tangent crest vertical curve is 1,000 feet long and connects a 2.5% and a negative 1.5% grade. If the design speed of the roadway is 55 miles per hour, how does this curve have adequate passing sight distance? So we're going to investigate whether the given design for that particular curve is adequate for a passing sight distance. So for that one, we have our equation from the design. The design speed is 55 miles per hour. So we use L, which is equal to K times A. So our L here is K times A. And from our table 3.4, so the value for K for the design speed of 55 miles per hour is equal to 289. So that is the value for our K based on table 3.4. So therefore, with that particular value using this equation, so L here would be equal to 289 times our A, which is G sub 1 minus G sub 2. So it gives us 4. So that is the absolute value. So therefore, we can have here the value which is 1,156 feet. So this is the length of the curve that would uh, have that will have an adequate passing sight distance. However, since our given design for the length of the curve is only 1,000 feet long, so which means that this design is not adequate for having an adequate passing sight distance. So let us try to check again using our K for the existing design to compare with the required passing sight distance based design. So from our equation, K is equal to L all over A. So if the given L is 1,000 and our A we have computed the absolute difference is equal to 4. This is 4. So this will give us 250. So 250 is still less than our value for the design curvature, which is 289. So therefore, we could have the conclusion that the curve doesn't provide adequate passing sight distance for 55 miles per hour. Okay, let's move on to underpass, sight distance, and sag vertical curve design. So in our previous discussion, we learned that design for sag curve is actually based on nighttime conditions. Since during daytime conditions, the driver can see the entire sag curve. However, in the case of a sag curve being built under an overhead structure such as underpass, so a driver's line of sight may be restricted so that the entire curve length is not visible. So we have here an illustration for our stopping sight distance consideration for underpass sag curve. So in the design of the sag curve, it is essential that the curve be long enough to provide a suitably gradual rate of curvature such that the overhead structure does not block the line of sight and allows the required stopping sight distance for the required design speed to be maintained. So we have here the illustration for our uh, SSD consideration for underpass sag curve. So for this one, we have our H1 to be the height of the driver's eye, H2 to be the height of the object, and of course that distance from H1 to H2 is our S, our sight distance, and that is actually connecting to that line. This one is our line of sight. And of course, from the line of sight towards the curve, we have our H of C, which is our clearance height. So we have our PVC, the initial point of the curve. PVT is the final point of the curve. Drawing a tangent line from initial grade and the final grade, you have your point of intersection, which is our PVI. So the total length, our L, is from PVC towards PVT. That is the total length of the curve. So again, by using the properties of the parabola for an equal tangent vertical curve, we can have the minimum length. We can get the value for the minimum length of the sag curve for a required sight distance and clearance height. So we have here when our sight distance is less than L, so we have this using this equation. So our H of C is the height of clearance, H1 is the driver's eye height, and H sub 2 is the object's height. A is the absolute value difference, absolute value in difference between G1 and G2. S is the sight distance. And of course, when the sight distance is greater than L, we can have the minimum length of the curve to be in this equation. Of course, L sub M is the minimum length of the curve, and our A is the absolute value of the difference in grades. So according to AASH 2, based on their design guidelines, if we use the driver's eye height, H1 to be 8 feet for a truck driver, and the object height, H of 2 is 2 feet for the tail lights. So if we try to substitute the value for S, which is equal to SSD, so we can have S when SSD is less than L, so we have here our L, which is equivalent to this equation. When SSD is greater than L, so we have here our equation for the length of the curve. So of course, our SSD is our sight distance, stopping sight distance. So we have to take note that in the case where there is an existing subcurve alignment and new overpass structure is to be built over it. So we have to take note that these equations are used for construction of a overpass structure. Okay, for our problem, an equal tangent sag curve has an initial grade of -4% and a final grade of +3%, and a length of 1,270 feet. An overpass is being placed directly over the PVI of this curve. At what height above the roadway should the bottom of this sign be placed? So for this one, we are going to compute for the necessary clearance height based on stopping sight distance. So we are going to, for the design speed, so that we could identify the design speed, we have to identify or determine the value for K. To start with our solution, of course, K is equal to L all over A. So L is 1,270, A is the absolute value in the difference between G1 and G2. So -4 minus 3. So it gives us 181.4. So if the value for K is 181.4 based on table 3.3, when K is equal to 181, our design speed is equal to 70 miles per hour. So, and the stopping sight distance is equivalent to 730 feet. So since our SSD is greater than our L, so I know our L rather, sorry, our L is, since our L is greater than SSD, so the equation is L is equal to A times SSD squared all over 800 times H of C minus 5. So from this equation, we're going to have the value of the clearance height. So the clearance height, which is H of C, will be equivalent to A times SSD squared all over 800 times L plus 5. So therefore, we have 7 times 730 squared all over 800 times 1270 plus 5. So this will give us 8.67 feet. However, based on AASHTO, the minimum clearance height, according to AASHTO, the minimum clearance height is equal to, this is the minimum clearance height, 14.5 feet. That should be constructed from the bottom to above the roadway. So from the bottom of the overpass, the clearance height should be placed at least 14.5 above the roadway. So this is the minimum requirement for the clearance height based on AASHTO. However, as per AASHTO, the desirable height or the desirable clearance height is equal to 16.5 feet. So this will be adopted, which is the desirable clearance height for an overpass construction.